Welcome back to the session, students. So in this session we will be seeing about image restoration. So what is image restoration? As we know, so we will be capturing the image, so that is sensing the image. So while capturing the image, there may be the lens may not be placed at the appropriate place, or there may not be a proper light source to capture that particular image, or some information may be lost while capturing that particular image. So in that case, what we have to do is we have to go for restoring the image. So we have to bring back to the original image without losing any particular information in that particular image. Okay, so that particular process is called as image restoration. So in this session we will be seeing how that image is being restored. So there are various techniques and models that are used in image restoration. So on completing this topic, you will be able to understand what is image restoration and what is the model of image restoration or degradation. So the main objective of image restoration is we have to improve the quality of the digital image. So as I told you, the image may be degraded due to various phenomena like the motion of an image, that is camera. So second thing is improper focusing of camera during image acquisition, and third one is external noise. So this particular external noise can result in blurring of image. So these are the major three factors which causes the image to be degraded. Okay, so what we have to do, we have to go for removing all these three factors, and we have to go for restoring the image. That is, the quality of the image has to be restored without degrading the original function. So this is the model of an image restoration. So main thing is the purpose of image restoration is to restore a degraded or distorted image to its original content and quality. So this is the model of degradation. So first what we have to do is we are taking an input image. So that is given as f of x comma y, that is my image f is lying along the axis x and y. Okay, so then it is given to degradation function h, and then this is the model of degradation, and now we are going to apply inverse process to recover the original image. So we can see that the noise eta of x comma y is being added, and it is providing an output, that is g of x comma y, and it is then given to restoration filter. Okay, so up to the summation symbol you can see that it is the process of degradation, and after the noise is being added we are going to process and remove the noise. So that particular phase is called as restoration. Okay, so we are giving to some restoration filter. The restoration filter can be any types of filter depending upon the noise that is present. So there are various type of filters such as impulse filter, Wiener filter, salt and pepper noise removing filters. So whatever the filter may be, we can go for choosing that particular filter depending upon our need. Okay, so depending upon the applications we can choose the filter and we can go for restoring the image. So once the image is being restored, the particular input image is being denoted in the output as f cap of x comma y. So this is just the model of image restoration. Okay, so here I have again given the explanation of diagram. So we are assuming the degradation function is existing. Okay, so along with that we are having additive noise which is getting operated on the input image f of x comma y to produce the degraded image g of x comma y. Okay, so next thing is the main objective of restoration is we have to obtain an original image from this particular degraded version g of x comma y. While having some knowledge about the degradation function h as well as the noise, we know what is the degradation function is and as well as the noises. Okay, So by using this particular two basic knowledge, we are going to restore the original image. So this is the mathematical expression, that is degraded image in spatial domain can be given as g of x comma y is equal to h of x comma y convolution f of x comma y plus eta of x comma y. Okay, so that is the noise that is being added is denoted as eta of x comma y, and here we are using convolutional operator. As we know, we can go for using spatial masking technique. So in spatial masking technique also we will be using this convolution technique. So convolution technique is nothing but we will be just placing a mask of image over that particular matrices of image pixels. Okay, so therefore in the frequency domain we can give it as g of u comma v is equal to h of u comma v f of u comma v plus n of u comma v. Okay, so this is how it works. Okay, so now it's your turn, students. So this is a quiz question that is based upon image restoration. As while explaining you, I told you different types of filters that we can go for using this image restoration. Now you have to tell me which filter can be best for using this particular image restoration function. Okay, so that's all about image restoration. I hope you all had a very useful session knowing about image restoration and what are the different types of filters that can be used in image restorations. Thank you for watching this video.